Hello, and welcome to BioTeam 4 presentation over enzyme kinetics. I'm Isabella Club, and I have my partners Whitney, Sage, and Ashton that are going to go over this experiment with us today. First, I would like to tell you the goal of our experiment, and the goal of our experiment was to determine the parameters and variables that would affect the Michaelis-Menten constants for the enzyme beta galactosidase the most. We decided to vary the parameters temperature and the concentration of the substrate. Our temperatures were 35 degrees Celsius, 55 degrees Celsius, and 60 degrees Celsius. And I would just like to go over a little bit the importance of enzymes. Enzymes will provide evidence for the mechanisms of chemical processes, and they also allow the scientific community to better understand organisms and develop different medications to treat diseases. That is why it is so important for people in our department and people in our industry to understand what enzymes do and how they work. This presentation will go over materials and procedure, the equipment and data, design of the experiment, purpose of our data, and our safety. First, we are going to go over the materials and procedure, and I will hand this off to Whitney in the lab.
Hi, I'm Whitney Sheffield, and I'll be going over the materials we used for the experiment and then also the procedure. So first off, the materials we used. So we used OMPG as the substrate, and then sodium phosphate dibasic for our buffer, and then lastly we used beta galactosidase for the enzyme. So first step of the procedure is to make dilutions of the previously mentioned materials, and then we made solutions, 3 sets of 6 test tubes worth of solutions with varying amounts of the OMPG substrate and distilled water, and those were the only 2 things that changed. So after the test tubes were all made, we came over here and we would turn on the hot water bath, which Ashton will explain a bit more in his section of the equipment. So after the hot water bath was turned on, we heated it up first to 32 degrees Celsius, and then placed 2 sets of the solutions, so the test tubes, and we would just take those to the walls of the hot water bath and allow that to heat up, along with some of the enzyme dilution, so that way it also was heated up with the rest of the solutions. Next up, we would prepare an assay of the no OMPG solution to zero the spectrometer. So, take the assay, we would get some of the solution with no OMPG, so no substrate, therefore no color change, and we would take that, put in the assay, come over here, drop it in, there's already an assay in there, and then shut, and again, Ashton will go over exactly how to work the spectrometer later on. And that would zero out the spectrometer so that we would get a good blank for the rest of the readings. And then next up, for our actual measuring of the rest of the solutions, or the absorbency for the rest of the solutions, we would start with one of the room temperature solutions, some of these. And then we would add some of the enzyme dilution, so 0.5 milliliters of the enzyme to the solution. Prepare, and then once you add the enzyme, invert to mix, and then take some of that into assay. And then as soon as the enzyme was added, we would start a stopwatch, so that way we could record, how long the enzymatic reaction was going on, and then immediately place the assay into the spectrometer, shut, read absorbencies. And then that procedure was repeated for each of the test tubes and for each of the varying temperatures. And we varied temperatures at 32 degrees Celsius, 55 degrees Celsius, and I think we did 1 test tube at 60 degrees Celsius. And that's it for the procedure.
Thank you, Whitney. Next, we are going to go over the equipment and data being read. Ashton will also take you through everything that you will need to know about the equipment, and here he is in the lab today.
Thank you, Whitney. I'm Ashton Downley, and I'm going to be going over some of the equipment we used as well as how data was collected. I'll start off with our Karstein heating module. The first thing you're going to want to do is you're going to want to turn it on, Then you'll direct it to the temperature that's desired. In our case, it was 32 degrees Celsius by using these up and down buttons, and then you'll hit set. And it will heat up until it's ready, in which case it will beep every 5 seconds. Next, I'll be going over how to use the spectrophotometer. The spectrophotometer is a bit more complicated. The first thing you'll do is turn it on, and the button to turn it on is on the right side towards the front. And once it turns on, you'll get a screen that looks something like this. It'll say Smart Start at the top corner. And what you'll want to do is hit the home button, then you'll go to live display. And with the live display, you'll want to make sure that the wavelength up here is set to 420 nanometers. Since ours is, you'll hit the home button again, and then you'll go down to scan. And now that you're in scan, you have to make sure that your blank is inserted. And if you notice up at the top corner, it says press this button to start baseline recording. You'll press this button, and it'll read the baseline. Once your baseline is read, it'll save it, and you'll go back to the home screen, and you'll go to Smart Start, and your option should be pictured here. Once you have the option selected, you'll have a method, and you can go back to scan and begin recording your data at 15 to 20 second intervals. And that was a summary we used for the equipment of this experiment. This experiment wasn't super long. The longest part of it was detailing the dilutions. And as for the equipment, it should be pretty straightforward as long as you can get a good baseline.
Hi, my name is Sage Coyne, and I'll be going over the design of the experiment as well as the purpose of the data that you collect for it. So in this experiment, you're going to be using a substrate called OMPG, and then an enzyme or a catalyst called beta-galactosidase. And for this, you're going to be placing those two chemicals within a test tube and attaching that test tube to the side of a water bath. And that water bath's temperature is what's going to be changed. So what we did is we did 35 degrees Celsius, 55 degrees Celsius, and 60 degrees Celsius. And the reason of this is we're trying to find the best operating temperature for the mixture. Once the mixture is taken out of that water bath after you've given it sufficient time to sit, you're going to add a buffer, and this can either be sodium phosphate dibasic or sodium phosphate monobasic. And you're going to try to obtain a pH of around 7.7 or so. And when you do add this buffer, you should notice some sort of color change occurring. And you're going to quickly try to put this mixture into the spectrophotometer so you can get a good reading on the absorbance. And now moving on to our purpose of the data. And the purpose of this is really to determine the Michaelis-Menten constants for the enzyme beta-galactosidase at multiple temperatures. And after running it, you should realize that all the OMPG has been hydrolyzed. And this basically just means that the final OMP concentration should be equal to the initial concentration of that OMPG. And from that, you can use the absorptivity of the OMP by calculating using this equation, it's Beer law. So the alpha represents absorptivity on ONP. The OD represents the optical density. The C represents the initial concentration of ONPG, and then the L represents the path length. And once you've calculated that absorptivity of the OMP, you're going to want to convert the units into terms of moles product formed over milliliters per minute. And then from there, you're going to want to make a graph, and this graph should be concentration versus time. And you're going to want to find the slope of the curve at t equals 0. And this should give you the initial velocities. Then you're going to want to create a Liner-Weaver-Burk graph of that OMPG substrate. And this graph should give you a straight line, which should make it a lot easier to find the Michaelis-Menten constants, Vmax and Km, using the slope and the intercept.
Thank you, Sage. Now I will go over the safety precautions that you would need to go through for a lab such as this. It is important that we would have eye protection and nitrile gloves. The different components and materials that are used would be the sodium phosphate dibasic that is anhydrous. This chemical is not considered hazardous by the 2012 OSHA Hazard Communication Standard. The beta-galactosidase is also not hazardous. Is not a hazardous mixture. Then we also have the nitrophenyl beta-galactopyridoside. This is considered an irritant, which is why it is important to have the eye protection and the nitrile gloves. Another consideration that you might want to take into account is we do have a hot water bath that is considered in this lab as well, and I would want to make sure the temperature of the water is not too high in order to cause possible burns whenever reaching in for the equipment. And if you do decide to do something like this, then make sure you have the proper handling tools. That is our overall presentation. The goal of this presentation, I hope that all of you would be able to understand the goal of this experiment, the materials and procedure, the equipment used, the design of the experiment, the purpose of the data, and the overall safety that you would need to follow for this experiment. Thank you.